Hi there! In this video we are going to create artifacts we need later to build Graphene dashboard. You know that we are working with New York taxi data and our machine learning problem is to predict the duration of each trip in minutes. If you follow in the course from the very beginning, which is indeed the recommended way to do that, you might already have all needed data and model. In this video we are going to create also the reference dataset, because we are going to calculate at least one metric, which is data drift, which requires that. But just in case you do not have those artifacts, I'm going to create machine learning model and load data as well. So if you, for any chances, do not have it, you can follow me and see how to build all those artifacts. So at the end of this video, we will have all needed data and models to build Graphene dashboard. So let's get down to it. You can see that I still have my Docker container running. Currently I do not need that, so I will create one more tab in my terminal. Let's do that. Now I need to activate my Conda environment. Here we are, and now I'm going to stop my Docker container. Now it's stopped. We will create two folders. First models, second data. There we will place datasets, reference data and models as well. So now I'm going to run my Jupyter notebook and implement all the code we need. Let's create new Jupyter notebook. I will call it baseline model New York data. Or better, New York taxi data. That's it. So let's add some label to our code to make it more readable. I called it baseline model for batch monitoring example. And now let's start from importing all the libraries we need to create model and load our data. So I would start from the standard libraries like requests, because I'm going to write a code which loads our data from the internet. It will be pretty useful because if later you decide to create your perfect pipeline which starts from the loading data from the internet, you could reuse this code as the first task in your flow. So I'm going to import requests. Also, I would import data, because obviously we are going to work with datetime data. I'm going to use pandas, so I imported pandas, and I'm going to add a couple more libraries like tqdm, what else, joblib, because I need to load and save my models, and I would import a couple of things from scikit-learn, because I need to train a linear regression model and estimate its quality. I think that's it. Now I'm going to write a code which downloads data from the internet. You know that we are working with green trip taxi data, so we are going to take data from January and February 2022 and save it locally in the data folder. So I will start from listing the files we are going to download. I will create a list of tuples, and first part of my tuple will be file name, and the second will be destination where we are going to save this file, which means data folder. Now I'm going to iterate through this list and load each file locally. And I will add a couple of lines of code to add some login information to my terminal, like print what is going on. So what we basically did, we created a cycle which iterates through files and pass in our files list, and what we do is we know the URL where those files are located, so we create the URL to download the particular file. In our case it's trip data, green trip data 2022 February and January in Parquet format. So basically we generate this URL on the fly, right? Then we create the request get, which takes our URL, and we implement and we use stream equals to true. Then we create a path where we need to save our file locally. So basically this is the path from here, and we add the file name to this path right there. And then we open each file in a write in binary mode. So, and then using TQDM to get some information about the progress, right? What we do is we actually write the data here, but also add some information to terminal in order to see what's going on. And let's check. Basically, it's successfully ended now, so we have all our needed files downloaded, and we are going to use those files to create model and then implement, let's say, more simulate the production usage of our prediction service. We are going to use January data to build a model and create the reference data set from validation part of data, because basically the validation part of data would be a part which didn't take part into model training, but where we can estimate model quality. And if we will like model quality, then we can reuse those validation data as the reference later, right? So, and our February data will wait for like next videos where we are going to implement simulation of production usage of our service and build some monitors in Grafana. So let's get down to it. First of all, let's read our data into pandas data frame. I would call my pandas data frame Jan data, like January data. So you can see that it's loaded, and you can check basic statistics about our data frame. For example, by calling method describe, by calling shape, so we can see how much data we have and what are the basic characteristics. So I would start from describe. Here I can see that I have pretty much information. So the most interesting is that I have date times for pickup and drop off, so I'm able to calculate my target, which is trip duration in minutes, to follow the initial model you built at the very beginning of the course. So I'm going to recreate that here in case you prefer to run the whole Jupyter notebook and have all your artifacts there. So I also have a lot of features like passengers count, trip distance, fare amount. All those are going to be pretty useful in terms of prediction duration, right? So I'm going to select maybe 3 or 5 columns to use as features in my model. So that's pretty interesting. I suggest you to go through the columns and analyze what you have in the dataset. I also want to see how much data I have for January, so I'm going to also call for shape. Well, here I can conclude that we have enough information to train simple model. So now let's create a target. Let's do some simple data preprocessing and move to model creation. And here I want to tell in advance that I'm not going to run a lot of proper experiments with different algorithms and hyperparameter optimization, because that's not our goal. Basically what we want to do here is to create baseline model, generate our reference dataset and that's it. So I will simply create the linear regression, and if you're interested in building a better model, you can invest some more time into experiments. It's especially interesting if you will use some tools like MLflow to check your experiments, because it will add some reproducibility to your code. So now let's build the baseline. First of all, I will create a target function. Those will be duration of the trip in minutes, so let's create such column. Those will be the difference between drop-off and pickup time, and in order to get it in minutes, we need to divide it by 60, and basically that's it. So let's write it. Now we just calculated our duration in minutes, and basically we are interested to see how our target function looks like. For doing this, you might want to calculate some simple statistics like mean, max, standard deviation and stuff like that. For example, you can do that with help of describe function, or maybe just see it visually by using the hist function from data frame. We're definitely going to see the histogram later, and now I suggest to pre-process our dataset a little bit in order to make sure that there is no outliers and we still have enough data to filter on some, and maybe it will help to get a better model. So let's do that. First of all, I want to left only rows where the duration, time in minute would be more than 0, of course, and less than 60, so I prefer to have only regular trips. And also I want Might to filter some other columns, for example the passenger count or trip distance or whatever. Basically I analyze the output of my gen data describe and see what I want to filter out, and now I see that passenger count might be filtered because sometimes there is like 0 passengers, sometimes it's 8. I believe that I would keep the amount of passengers from 1 to 6. So let's write it as well. So I would copy some code from here. I would limit myself here, but again, if you prefer to filter more roads, why not? Now let me check the distribution of my target function. To me it looks more or less okay, and actually I would stop my filtering out of outliers there and use those data to model training. So let's move to model training. Prior to train model, I would like to select what features I'm going to use from my dataset, and I want to limit myself to 3-5 features. So let's check again what do we have in our dataset. So I think passenger count, trip distance, fare amount looks good. Total amount as well. And I would also take a couple of categorical features like location ID, PU location ID, and TO location ID. So let's write down what we are going to use as the features, because we will need those lists later. So I would create all the variables to describe what I'm going to use as the target and features, and then just reuse those variables instead of writing down the exact names. So just help me to work with the data a little bit more convenient. I think that's it. So I pre-selected, let me count again, 4 and 2, 6 features, for numerical to categorical, and now I'm have everything to split my data into training and validation and train baseline model. Again, for now I skip the experiment part, but for production model it's very important to make sure that you selected the right algorithm with correct hyperparameters. So now I will just train the linear regression and let me split my data into training and validation parts. So let me check how much data do I have. That's pretty a lot. So what I'm going to do is just split it very easily into 2 parts, and first part would go to the training and second to validation. I know that my data is ordered by date time, so I would prefer to keep my first part of data frame as the training data and the rest one as the validation data. So in this case, as I'm working with time series, that's more or less okay. So let's do that. Yep, here we are. Now we can create the model and train it on top of training data and later validate model's quality. As promised, I would go for linear regression without any arguments. But of course it makes sense to run some experiments there, so I will just create a simple model. And now let me apply it in order to get my predictions. Of course, before I need to fit my model. That's it. So you can see that the model was trained pretty fast, and now I can apply my model to training and validation dataset in order to check the quality and save the predictions, because I need to have it in my pandas data frame for future analysis. And you can see that I have some warning here that makes sense actually, and I would agree that it's better to use .log to write a slice of pandas data frame, but just for the sake of doing it fast I would keep the same version of code. So let me just substitute my training dataset to validation dataset and create predictions for my validation data. Okay, now I have my predictions written into pandas data frame for validation and training data. So now let me check the quality with help of mean absolute error and mean absolute percentage error metrics. And if I would be happy with the quality, I would basically dump my model in order to reuse it later in my prediction pipeline and for monitoring. So let me check the quality. I would keep it pretty simple here, so I can see that my mean absolute error is more or less equal to like 4 minutes. You can see the values here, and I would say that I'm okay with that, especially taking into account this distribution, so might be better, but still okay. As we are okay with this model as the baseline, let's dump it for future usage, and let's also create a reference dataset. So I will add a new label here. Dump model and reference data, and now let's quickly discuss our reference data. For calculating features like dataset drift, data drift for individual columns, or prediction or target drift, we need to compare the distribution which we observe currently during the production usage of our service with the distribution on top of some data where we were happy with the model's performance. So basically in our case we already have such a candidate, which is validation dataset. So what I'm going to do is to save this dataset and later use it as the reference. So here I'm going to first dump my model and then dump the validation dataset and call it reference. So let's do it. So what I'm doing here is I'm trying to dump my model into output, and my output is models. We created this directory at the very beginning, and I would call it, like we did before, len regression.bin. And now let me just save the validation dataset. So I'm just using pandas toParquet method, and I will call my data reference.parquet. Basically that's it. So now we have our source datasets for January and for February. We also created the reference dataset, which we will use later to calculate metrics, and we finally have a model which we are going to use in order to simulate production usage of the duration prediction service, and we will use this model later when we will implement the calculation of metrics for monitoring.